Welcome back. My name is Delmico L. Cunningham, better known as Dr. Media. So, in our lessons this week, we've really been looking at dynamics here inside of Maya. Well, for anyone that's ever done dynamics inside of Maya, if that's done rigid and soft body dynamics inside of Maya, you will know that the Maya dynamic system is very old and it's been inside of Maya for a very, very long time. Now, with that being said, there is also the brand new Bullet active rigid body and soft body system inside of Maya. But there are problems with both. The big problem is that the Bullet solver works really well on large scale simulations, but the constraints for the Bullet solver are not the most, I will say, dependable. They can be rather erratic at times. So even doing simple things like doing a pin constraint with the Bullet rigid bodies, they can bounce around and have really weird kind of effects, which is really odd. So for this particular piece, we're going to use the traditional Maya dynamics, and if we do this right, then we should have very little problems with the original dynamic system. It's not going to be that difficult of a thing. And I'll also be showing you how to keyframe your simulation starts, and also how you can get things to settle and do initial states and all those things. And we're going to be doing it all in this video series right here. So one thing that I want to do is I want to actually go ahead and make myself another piece of geometry, because I want something to actually toss from my catapult. And we're going to talk about, as I drag out this little sphere, we're going to talk about some things about this catapult and how this model was constructed. So this model realistically was constructed as individual pieces. And what I mean by that is that this cross member is a piece, this piece right here is a separate piece, this is separate, this kind of pin is separate, the base is separate, the arm, now the arm and the bucket I left as one piece because it's just like a gigantic, it's like a giant spoon almost. So I left this as one piece realistically, but everything else is separated. So the other thing I want to do is I want to make myself something to throw this at. So let's make ourselves some boxes, just something to throw this at. So I'm going to come in here and just make myself a cube, wall, and yay high. And then I'm going to duplicate that, Control D to duplicate it. Once I've duplicated it once, I can then use duplicate with transform. So I'll hold down the shift key and press D. And you see that duplicates with the same spacing on all of those, which is kind of cool. And then Control D to duplicate, and make sure we get them all. So Control D to duplicate, pull all these guys up, and let's pull them over a little bit, something like that. And I'll go back to my first row again. So I go back to my first row and select these guys again. And then duplicate those, pull those straight up, come into my middle row, and duplicate these, and pull these straight up. And then one last row, so duplicate again, and then pull these up right here. So I've got a bunch of duplicates. I'm going to grab them all. I'm just going to move them out a little bit, like kind of over here. So that looks good. And you see I'm moving them in one axis at a time. Now the other thing that you want to make sure that you do not do with your dynamics, you're going to have the mindset of, hey, I want to freeze these translates. Do not do that. One thing that you can do is you can group something to itself. If you group something to itself, then it will actually zero out its transforms and everything else. But just know that even the grouping sometimes can give you issues. So the best thing to do is just to keep your objects separate. Now, the one thing with your dynamics, not the only thing, but one of the things with your dynamics is you really can't move pieces around. So the way dynamics work is that the dynamic system will try to figure out the rotate, the scale, well, not even, yeah, we'll try to figure out the rotate and the translate of objects inside of your world. Now, it doesn't like it when you move those objects around unless you've turned off your simulation system. So I'll show you how you can turn off the simulation system inside of Maya. So I'm going to come here and I'm going to go to soft body, soft and rigid. Make sure I am in my dynamic set, and I'm going to make this ball an active rigid body, and this arm will be an active rigid body. These pieces here will be passive because they're not going to be moving. This is passive, and this is passive, and then this guy right here is also passive because he is not moving anywhere. So all those are set right now. I've got a floor in here. I'm going to click on my floor, and I'm going to make that passive as well because it should not be moving. And let's just set it to a tracking. So if I play this back right now, nothing happens because I don't have a force inside of my world. I need to add gravity. So I'm going to click on my ball and click on the arm, and then come here and say fields and say gravity field. So now those two are being actually manipulated by the gravity field. I'm just going to pull the gravity field out here like that. And so now you can see they both drop and fall. Now, the thing that I need to do with my arm needs to have some kind of hinge right here so it can kind of pretend like this pin is actually there. So I'm not going to use a pin constraint. I'm actually going to use a hinge constraint. And I'll show you why. If I go to my top view, and I'm going to go in here and go to wireframe, you'll see that I actually have like this bar inside of Maya. And if I rotate this, guy just like that, I'm just going to come in here and boop. So if I rotate this bar and then move it, let's move my bar up here. And then I'm going to get my scale tool and I'm going to scale it as wide as my pillar pieces. So now what this does, if I actually look at this and let's rewind and hit play, you can see now this is a hinge like it should be. The ball's sitting in here, it hinged up. Now I need some kind of power to pull this up. Well, in real life, this would have had a rope roped around it, and it would have had really tight tension put on it. And it would have been, this would have been pulled down towards the ground over here, and this would have been bent back, and there would have been a whole bunch of torsion and torque and everything else. But for our simulation, we're going to cheat, and we're going to use a spring constraint. So I'm going to click back on my kind of arm lever here, and I'm going to click on spring constraint. And with that, I actually get this little spring. I'm going to go to my left view. I'll go here to left. And I'm going to take this string and I'm going to pull this guy right here to where the center of kind of my brace bar is for my catapult. Now, the reason why I do that is because if I rewind my simulation and play this back right now, you'll see it has a little bit of a bounce to it. It actually bounces. This spring right here actually does what it sounds like. It is a spring. So it is actually set up for me to, if I go in here and look at my attributes, I can go to my rigid solver, my rigid spring constraint solver rather, and you can see spring stiffness right now is 5. If I put this at a 10 and then rewind this and then play this back, you can see that the ball doesn't have time to actually weigh itself down. It starts to move forward. If I turn this stiffness up, you'll see now my ball is getting thrown a little bit faster. And then I can rewind this again and turn this. So now you can see my ball has got even more spring to it, and you can see where it's going to go to. Now remember, these bricks do not have any kind of dynamics on them yet. They're just bricks that are sitting there.